Alexis Robinson. This is Lab 1. This is my table of contents. I have intro, tracker, glow script, compare, and questions. The goals for this lab were to record an object moving at constant velocity and measure it, and to compare the observed results to the expected results. The assumptions that I made in this lab were ignoring air resistance and friction and only measuring the x-axis because the code that we used didn't really take into account those things, and the object's only moving in the x direction. The important topics for this lab were the idea of constant velocity, in which constant velocity means that the net force is going to be 0. This is my free body diagram to the right. The system is the car, and the surroundings are the track, gravity, like everything else around. Newton's first law is that an object in motion will stay in motion and an object at rest will stay at rest unless something changes that. And then Newton's second law involves the velocity update and position update formulas. So these were important because we pushed the object, which got it into motion, and then something slowed it down. And these formulas are used to do our calculations. This is what was graphed from the observed position. V average, I calculated over here. It came out to be 0.0722 meters per second. And then this is the expected position based on the code. Here are my initial conditions, the position and velocity. And then here are my iterations in the code. And then over to the right is the results from all of that input in the code. And the expected is the orange and the observed is the blue. Obviously the expected is a bit more linear because it didn't take everything in real life into account. And then the observed results were not as linear because there are a lot of things going on in real life that the computer couldn't account for. And there were plenty of forces acting on the object that we used that we couldn't account for. Possible errors were differences due to ignoring the air resistance, friction, and all of the other forces that could be acting on this object. And the tracker also may not have been completely accurate because we had to track the position ourselves, and also it assumes a mass of the object, which could be different than the actual mass. For the what if question, if the axes were changed, the slope of the graph would be negative instead. And for the what does it mean question, we can assume that the pushes and the pulls were equal to create that net zero force, but it's impossible to know exactly how many pushes and pulls were used in the force because it's hard to measure that stuff in real life. And that's it.